It's time to build your first Flutter app or project. To do so, we will use the command line interface method. All Flutter commands begin with Flutter, and to create a new project, you have to use Flutter create project name. The project name you choose will also become the name of the folder where your project files are stored. Keep in mind that Flutter prefers using underscores in project names, like my_app, rather than camel case, like my app with uppercase A. For instance, running Flutter create my app will trigger Flutter to generate a set of files and folders. Some of these, like analysis_options.yaml, pubspec.lock, and myapp.iml, can be ignored for now. The generated directories are quite self-explanatory. Android, iOS, Linux, macOS, web, and Windows contain platform-specific code and assets for running your app on those systems. The lib folder is where your Dart code resides. Initially, it includes a single file, main.dart, which serves as the entry point of your app. You can add more files and folders as needed, but main.dart must always be present. The readme.md file provides basic documentation about the project. pubspec.yaml serves as a configuration file that manages dependencies and other project metadata. We will not explore these more in depth in this course, and you can leave it as is. When a new Flutter project is created, main.dart isn't empty. It comes preloaded with a simple demo app that you can run immediately. Right now, we have no idea what the app is designed to be because we haven't examined its source code. We also don't yet know what platform or device it will run on. Once you open the newly generated project folder and enter the command flutter run, Flutter will detect available environments and provide two primary options. Your current operating system, for example, macOS if you are using a Mac, and the web-based option, which launches the app inside the Chrome browser. You are free to choose either option to see how the app runs, or you can exit without launching it. While both versions look and behave similarly, there is one notable distinction. Running on a desktop operating system like macOS opens a native application window, whereas the web version displays the open inside the browser. If the previous options don't meet your needs, you can also test your app using emulators. By running the command flutter emulators, you will see a list of all emulators currently available on your system. For example, on my Mac, I have access to an iOS simulator thanks to Xcode, and I have also set up an Android virtual device, AVD, a medium-sized phone running API level 36, which was the last Android version when I created this content. To start an emulator, you can use the following command: flutter emulators --launch emulator ID. This will boot up the selected emulator. Once it's fully loaded, it's ready to run Flutter apps. When you launch your app, Flutter Run, Flutter compiles the code and deploys it straight to the emulator. It's important to note that iOS and Android builds follow different compilation paths. iOS builds is based on Apple's tool change, while Android uses its own set of build tools. Although Flutter provides a command, Flutter emulators -- create, to generate new emulators, I suggest managing them through graphical tools like Xcode for iOS or Android Studio for Android. These tools offer a more intuitive and streamlined experience. To help illustrate these, take a look at the two major emulator options: the iOS simulator on the left and the Android emulator on the right. When you run the default Flutter app on either one, you will notice a straightforward interface featuring a floating action button, a plus icon, at the bottom. Pressing the button increases a counter that starts at 0. While simple, this example highlights how the exact same Flutter code runs smoothly on both Android and iOS devices. One of the Flutter's standout features is its ability to maintain a consistent UI across platforms. This consistency is possible because Flutter uses its own rendering engine rather than relying on a native UI component. In this case, the interface is built using Material Design, a visual design system that not only comes standard with Flutter, but is also the official design language for Android and widely adopted across Google's products. Thanks to this, the app looks and behaves identically, no matter which operating system it's running on. As mentioned earlier, Flutter supports two primary UI design systems, Material and Cupertino. Material Design, developed by Google and currently at version 3, is a visual and interactive framework that defines how interface elements like buttons, input fields, cards, and menus should look and behave. It isn't tied to a specific programming language. Rather, it provides a set of design principles and component standards. If you are targeting iOS or simply prefer Apple's design style, Flutter also includes the Cupertino widget set. These components are based on Apple's human interface guidelines and mimic the native appearance of iOS and macOS apps. It's important to understand that these design systems are independent of the actual platform your app is running on. Whether the app is deployed on iOS, Android, or the web, Flutter handles the low-level platform interactions. The design system only influences the UI's appearance and interaction style. In my own development, I tend to rely mostly on Material. It's better integrated into the Flutter framework. Most learning resources and examples use it, and for building apps that run consistently across multiple platforms, it's often the most efficient option. While it's totally possible to build with Cupertino, doing so usually involves writing slightly different widget code, but not dramatically different. Not exactly the same either. Now, let's try to focus on a few peculiarities of Dart, and then we can try to start writing some code.